Hello everyone, today is day 2 for update DSA preparation. So the 5 problems I solved today are: the first one is this, the diagonal tree transversal. Second is zigzag tree traversal. traversal. Third is sum of nodes on the longest path. Fourth one is lowest common ancestor in a binary tree. Third is KSM path. Okay, so the first one is diagonal tree traversal. So basically it was a bit similar to the problem I solved yesterday, which was uh, those like vertical tree traversal. It is a bit similar, but we are viewing from a 45-degree from the left side. So basically the key feature which we need to identify for solving is, for like when we are traversing, when we are moving in the right direction, like when we are going for no, node right, so we don't need to change the numbers. Like here 8, 10, 14 can be assigned 0, 0, 0, and 3, 6, 7, 13, 1, 1, 1, and last 1, 4, 2, 2. It's the same type of problem. Mm, Nothing else. Okay, great. This was the basic concept behind this. This was the zigzag tree traversal. So here we can solve it using Q. Great, we have solved using Q, and one thing and we also need to keep a flag or something. So basically, let's say if we have done in left to right for one level, for the next level we'll go from right to left, then left to right, then right to left. So basically this was a good, there is also a flag what I would have kept. This one, either we can use this or we can use the reverse function for reversing the vector. Both will be the same case. The main thing was going level by level using Q, and this was easy. When I got the code, I think I can solve it myself from some of the nodes on the longest path. Here also, binary tree, you need to find the sum of the nodes on the longest path from the root to any leaf node. So basically we need to find the longest path and the sum of nodes on that. So basically I think I did a very longer method. So basically mm, like here you can see, for the level 1 there is 4, for the level 2 there will be 4 to 6 on there, 4 to 9. Basically I create a dictionary for each level. So basically for the first level the dictionary will be like key is 0 and the value is sum 4. For the second level we can see 4 to 6 and it is 4, 5, 9. Basically I picked a higher value. So basically for the next second level it will be key will be 1 and the value assigned will be 9. I kept in the code like say this part is very interesting, like basically, and the rest I just from the recursion function. So this is method was a bit longer, like the method I took, but it was like very helpful. Like this approach can be used in various other problems. And one is lowest common ancestor and k sum paths. Let's do k sum path first. So basically this was also, I couldn't solve it for myself. I thought randomly and applied, but things didn't go as planned. So I watched the tutorial like solution. So here I came to know that we have to find like all the possible number of paths. So it was a beautiful example of recursion add. So basically it created a vector initially, and so here we have created a int vector, and basically from time to time, let's say when we are at node 8, in the vector will contain 8. When we will get 4, 8, 4. When we go to 3, 8, 4, 3. When we go to our bottom 3, 8, 4, 3, 3. And we will also keep on like checking if our sum is going to be like whatever k is there. So here is for the checking part, if the sum is equal to 7. And we have also defined the count here. The count is adding plus, and here is count by reference, and there is vector. This is recursion part. So main concept behind this was like, yeah, the main thing was this, like defining a vector path, thinking like this, like going like recursion and creating a path for while for each node. This was great. And actually the concept I learned here, I applied for this lowest common ancestor. But here instead of like there the we like we used int. We were expecting the int value like in count, and here we are asked for the node, like the lowest common ancestor. So this, I took the same path, just I created a vector containing node, and I just copied the last function. I just made a few changes, and actually I found these two paths, like 5 and 6. I found two paths. We know m1 and m2. Let's take this example. Great. So here we know n1 is 5 and 2 is 6. So I calculate the entire path. 1, 2, 6, 1, 2, 5. This is our one path, and 1, 3, 6. This is second path. I created basically two vectors. We can say I in global vector I created two, path 1 and path 2. I assigned to path 1 is 1, 2, 5. Path 2 is 1, 3, 6, and both contains node, not the exact data values. And here you can see this, after assigning sol, after using sol, I got these two. I got path 1 and path 2, and just it is similar to comparing two vectors, like when you know now, when two vectors have some similar values and some dissimilar values, we go from one side and check where is this is dissimilar. Just uh, dissimilar, then we check I minus 1 and then go for that. So similar size 1, size 2, I taken the minimum size. I liked iterated it from I is equal to 0 to lessons size minus 1, because here I kept I plus 1, and then I also have to do like handle some edge cases. So basically when I didn't include this part, I was getting an error, so I came back later and added this part. So this is the case for today. The diagonal traversal was easy, like similar to the vertical part. Here we have to think of like we're using queue and the flag concept. Here I did a longer method, but it was very interesting using of dictionary. I dictionary of map. You can map is better. Use of map, and for each level I only kept one value, like for 0 1 sum, for second 1, third and fourth at night. So even though it took a longer path to solve the problem, but yeah, it was very interesting. And for ksum I couldn't solve it on by myself, so I looked at a solution. Here I came to know that we can look for the all existing paths and then go for the sum. So this was, yeah, thing I learned today, and I use the same concept here, just include instead of using vector int I went for vector node. That's all for today.